discussing an interview with Drago Anguelov at the Trimmel podcast with Sam Charrington. Shout out to Drago and Sam. This is really, really important. So I'm very grateful for this interview. I think we're large Tesla and NVIDIA investors. We're betting a lot on autonomous driving and robotics. And there is very little actually tangible scientific information about how knowledge from science is being translated into the actual space. And Drago, he's head of AI research at Waymo, so he's really out there. I mean, this is about the third or fourth time that I met him. I mean, not physically, but through this podcast, and I also met him at CVPR. I met him at Stanford. So he's out there talking, and I really appreciate this. It's incredibly important for us as investors, I think, for the space to understand what the approaches are, what the drawbacks are, and discuss fundamental aspects. I think Sam's podcast. I think I would say his and the Weights and Biases podcast. I forgot the name. Those are the two best AI podcasts, in my opinion. Like for people like us who are sort of, we're investors, so we are involved. We have very high concentrated positions, so we're not just spreading. We're not Wall Street types. We actually do invest and have our own skin in the game. So we do have a requirement to understand pretty well what's going on in academia and science, and have the ability, and this is our job, to translate that into predicting the future, predicting where the wealth is going to be created. That's what we do. And I think we have a principle stack on our website for people who are interested in how we do this. We certainly don't day trade or listen to Wall Street analysts or anything like that. So our approach is to read scientific papers, or just generally attend scientific conferences. We spend a lot of time at Stanford and Berkeley just because we're based in the Silicon Valley. Listen to seminars and like really have the pulse of what is going on in science, and then see how that translates into into technology. And I think Drago is a perfect example of how this is done in the real world. This is not even on podcast. It's April 2nd, 2025. This is Krim Delco. For the day, we're up about 3%. Tesla has just announced their delivery numbers, which were way below expectations. The numbers are not good. There's a lot of caveats here: Model Y transition, political backlash. I think we just need to step back a little bit and think about this very deeply. How much? There's really three big questions, in my opinion. One is how big is competition? Like, is this a competitive problem? Second, do we have a maybe a saturation of electric cars, in the sense that, I guess what I meant is one, is there a competitive problem within electric cars, right? So is it true that people are buying more Lucids and Kias and things like that, or in China, whatever they're buying there? Second, are we losing the race against gas cars? And I think most importantly, actually, third is, what is it even we're looking at this point? Like I just put on X the other day a question, which is, okay, at what point will we stop looking at delivery numbers and just looking at how many miles Tesla is selling, right? So Tesla is disrupting itself as we speak. They're going from selling cars to selling miles. It's a whole different business model. This transition will be painful, and it is painful. We're down, 30% for the year in the fund. Tesla stock is down a lot. So this is not going to be easy, but of course, wealth creation, the kind of wealth creation that we're aiming with Tesla, is much, much more aggressive than I don't know, 10% annual returns or something like that. So you have to live with this volatility. But I don't want to spend too much time with the daily business right now, because I think this episode is really about sort of fundamentally what is science, what is technology, and how does it really apply to autonomous driving. So let's dive into it. So the interview is about the foundation model approach of Waymo, and I think this is, of course, the taste du jour right now. Everybody wants to have foundation models. physical intelligence company is coming out of Berkeley, is trying to do this for robotics. I think we have lots and lots of academic papers writing about this. We have spoken about this a lot. Tesla has even mentioned it sometimes. The idea of foundation models is, of course, okay, can we have a general model like a chat GPT for robotics? Now, when I talk robotics and autonomous driving, I think eventually those two things will be the same thing, but they're not the same thing right now. So we want to just focus on autonomous driving today, okay? So autonomous driving can be done in a modular, bespoke way. You can solve for highway, you can solve for inner city San Francisco, you can solve for inner city Phoenix, you can solve for suburbia, or you can do it more in a foundational way, which is a generalizable end-to-end driven way. And I think this is really where the demarcation line is right now, right? And I think one of the things that I take away from this interview is that, Waymo is using a modular approach, and that's where the history of the company comes from. If you will go way back, Sebastian Thrun and his people who started this whole endeavor with Waymo. In my opinion, that's the wrong approach, and I think Drago knows this, but he also has technical debt to deal with. So he's trying to get from bespoke towards general, and he has to deal with all the issues that come with that. Now let's just talk about what he said. Like I'm going to put my conclusion and also obviously I'm thinking, okay, how does this relate to Tesla, right? This is the key. So fundamentally, what I've noticed is that, for example, Drago said that they started solving suburbia in Phoenix, and then they started solving inner city in San Francisco, and then they went to LA, which combines it. So there's this bespoke approach towards problem sets or domains, which is very it's certainly not end to end, but it's also that I think that's the reason why I just feel that Waymo is not scalable, because it's kind of like search being it's exactly, I think I said that, which is very ironic. Waymo and Tesla is like Yahoo and Google, right? Yahoo was very good at travel search, much better than Google. They solved travel search, but they were not very good at academic search because they didn't have the expertise and the data. Google started and wasn't very good at anything, but then because it was algorithmic, started getting better and better and better, and then eventually took over because it was kind of more end to end, if you will. Now, what does end to end actually mean? Let's define this. This is a very nice definition. So end to end is you have to be able to pass gradients back and forth. This is what end to end really means. And there was a very interesting panel at NeurIPS 2023 where this was discussed also by a DeepMind person. I forgot his name. So it's about that. It's really like when we talk end to end, all we want to really focus on is, okay, are we passing gradients from in to out throughout the model, and is every modular part of the model being affected by the passing of the gradients? Now you might say, well, why not? Of course, the downside is you don't want to forget. You want to have things like catastrophic forgetting and things like that. In other words, if you have an end-to-end model, you come to the conclusion, and this is another quote from Drago's interview, which is you have to be able to validate something, right? There's two problems in autonomous driving. One is you have to teach the car to drive, but the other is you have to also validate. You have to make sure whatever you teach the car, is it actually learning? Is it getting better? How do you define getting better? What does it mean to have a better model relative to an older model? How do you test these things? And that's why Waymo is using modular approaches, because they want to be able to test each one. So this is, if you will, a sort of older version of software engineering. You have unit tests, you test certain things, and then you put it together. Versus, it seems to me that Tesla is using more of a software 2.0 approach, a more general approach, which is data in, large compute out. Now, unfortunately, we don't know exactly what Ashok and his team are doing. They're not the most prolific when it comes to informing us about their approach. There hasn't been an AI day for years. This is for another episode, why that's the case. We also don't see them at academic conferences. So Tesla is pretty tight-lipped. And I'm not sure that's a good thing, but it is what it is. Now, what we know from we know a couple of things. So one is Musk is betting on scale, whether with X AI or with Tesla, he's buying GPUs. So his approach is that FSD is a function of compute. So FSD follows Moore's law, and let's call it also Jensen's law, which is the acceleration of Moore's law through parallelism. In other words, just more compute, faster data throughput, more parallelization. So, just look at what Jensen's talking about at GTC and translate this to autonomous driving. That's what Tesla's betting on. We also know this indirectly from ARK Invest. They spoke about this, and Musk has said it's a good analysis. So let's say that's what they're betting on. What they're saying is that our cars will get better with more compute, and that's pretty much it, right? Now, Drago is saying, well, you can say that, yeah, but what exactly does that mean? Or do you also have more data? Then you can throw in Jensen's comments, which is, well, actually, data and compute are two sides of the same coin, because you can create more data with compute, i.e. synthetic, simulation. So compute is, in the end, if you will, really the bottleneck here. Or if you want to go even further, it's energy, right? Because you need energy for compute. But the point here is that in an end-to-end trained model where you pass gradients back and forth, you have to be able to validate models. And that's a big problem, and that's something that Tesla has admitted, that is a problem. So how they're actually doing this, we don't know. Drago is mentioning some of the problems. I think that's a very honest and sober way to think about it, right? I can have a big model and feed it a lot of data, but how do I know I get better? Now, having said that, just take an example. You could have a model which learns how to deal with cones on the road, and it understands that it has to pass the middle line. But then, of course, you don't want it to do this when there's one cone on the road by accident. You want to make sure that it understands the scene as it is. Which brings us to the foundation model question, which is, and we've spoken about this in the past, okay, how about semantic understanding of the world? Or how about building a world model? And also we've had clues from Tesla about that. We've had clues from Tesla that they are actually interested in transformer-based architectures or something along those lines. They're also looking at things like 3D visualization of 2D images. So they are doing all these things that academia is doing, Gaussian splatting, diffusion-based models where you take a 2D picture and turn it into 3D. They are doing all these things. So Tesla is certainly working on foundation model type approaches, which, by the way, doesn't exclude it doesn't mean they're using end-to-end or not. I mean, foundation models, you could think of, like, you can have any kind of model, whether it's LLM, VLM, you can have bespoke parts of a model that deal with suburbia and inner city. As long as you pass gradients through the model back and forth, it is really end-to-end. That's what it means, because you want to optimize the whole thing versus just parts of it. For example, if you want to use an analogy, you can optimize the supply chain of the Tesla Fremont factory and really have a very well optimized, or you can say, no, I want to optimize the Tesla production in the US, not just Fremont, but also Reno and Lathrop and Austin. So that requires a different type of optimization. Or you can even say, I just want to optimize for the global production of Tesla. So then maybe certain parts will be, instead of shipped from Reno to Fremont, they might be even shipped to China, because over there, there's a certain bottleneck that if you ship this part from here to China, you can save more, per car globally than if you just ship it here. So things like that. Like when you change the optimization scope, the optimization itself changes. I mean, this is, let's say for an operations research person, this is, I think obvious, right? Like you change the constraint and you change the goal, and you have different types of optimization. So you can think of end-to-end as kind of like a global optimization scheme where we optimize for the global production of Tesla and not just for Fremont or the US or California or the Southwest, or whatever sub module you want to use. So I guess to summarize this interview, it is my feeling, my hunch, that Waymo is sort of dealing with technical debt here, and they're up against uh, a more comprehensive end-to-end approach by Tesla. At some point, I think they will merge. So it's not this or that. It seems to me that Tesla is going faster because you have anywhere to anywhere only cameras, which is, in our opinion, it's a constraint that will also have a huge impact on cost, which is a point we're going to make in a second. But let's stay with the fact that we have this constraint in technological development. Very often, what you leave out is what really wins. So when Steve Jobs developed the iPhone, one of the biggest breakthroughs was he left out the keyboard. Leaving out the keyboard took years for the engineers to figure it out. Actually, they needed the iPad as a sort of bypass to figure out the typing on the screen and things like that. So leaving something out sometimes is the breakthrough, and I think in this case we believe that this is exactly how Tesla will eventually win, is because they left out sensors, and they also go from anywhere to anywhere from scratch. The other big point that wasn't even discussed with Drago, which I think we need to discuss here, because in the end that's what's going to be, that's the 800-pound gorilla here, and that's cost, right? We believe that fundamentally, even if you think that the software stack will be commoditized, what Tesla is going for is actually the cost. So Tesla is going to be the hardware provider for self-driving, because they have the lowest cost. And in the end, the lowest cost per mile will win, because that's what people will be selling and optimizing for, cost per mile. Now, there's, of course, a little bit of design and comfort and things like that. But let's say on that front, Tesla will win anyway, particularly on the design and comfort side, games, interior design, things like that. There will be a little bit of differentiation here and there, but that's fine. We don't need to worry about that. What we really want to focus on, what we really want to emphasize more than anything else, is cost. So Waymo's cars right now cost more than $100,000. We don't know how much they cost, but let's say they're very expensive. The operation also is relatively expensive. The maintenance, to have all these sensors, all of these things are expensive. And let me just bring this home. The problem with cost is not, let's say you take a Jaguar and you refurbish it to drive, or even what Kamaya is doing. I mean, that's great, good for you. Take a Toyota, or Rivian, and you make it self-drive. The problem is this: you want to optimize for a lot of miles, because that's going to be your main driver of bringing down cost per mile. It's not even the cost of the car itself. I mean, it's going to make a difference, yeah. But if you just take the cost analysis, like a very simple math, right? Cost divided by miles driven. So you have total cost of ownership of a car divided by miles driven, right? Let's say the costs are 50 versus 100, but the miles driven are a million versus 200, right? So you see, like, the math starts computing. Now, I'm not saying Tesla is ready to have a million-mile car, but they're definitely optimizing for a lot of miles driven in many ways, by the way. Starting with Tesla's a manufacturing company, and that's what's going to win in the end, because miles driven is going to drive down cost per mile. Not only, let's not underappreciate the fact that actual cost. I mean, to be able to buy a Cybercab for, let's say, $35,000 is still a third of the price of an ugly-looking Waymo car. And that's not Drago's mistake. I don't want to sound like I'm bashing him or anything. He's the AI researcher, but that's the problem here. I mean, that's something he's up against. I'm sure he knows it. Again, I just want to make sure I appreciate his contribution, and I'm not bashing Waymo here. But I'm a Tesla investor, and I have to make a case for why Tesla will win. I want to just to finish one more thing that actually Drago said many times, which is, how do we know what is good driving? Like, so when everything is said and done, so we have an end-to-end versus modular model. We have backward, forward pass, gradient pass. We know we have the model, but what's the reward function? Hello. That's the other 800-pound gorilla. What does it actually mean to be a good driver? And I think that's the fundamental edge that Tesla has here because of the millions and millions and millions of miles that they have been watching people drive. They have a good sense for what good driving actually means. The same way GPT had a good sense for what a good poem looks like, or Grok knows roughly what a good German, text looks like because it's just read a lot of them. It has a good sense. Yes, it's averaging out. It's not perfect. The Tesla driver is not as good as Hamilton or whatever the Formula One world champ name is. It's going to be an average driver, but that's all we need, obviously, for FSD. And then there's the edge cases. Another thing we want to say here is that there's a potential for some sort of function calling, a little bit like, let's say, if you call Grok right now and you ask them something, why is the market down today, right? What Grok's going to do, it's gonna go and pull websites because it doesn't know, it hasn't been trained obviously on today's data in order, so the pre-trained model doesn't know, but it can go pull websites and things like that. So we could have some sort of function calling where if the car is stuck between cones and workers and stuff, maybe it can call a certain function, maybe even a teleoperator, but some sort of function calling where we have bespoke solutions for very, very difficult edge cases that cannot be trained. And then, we can merge them into the training set. So there's a lot of inspiring talk here. But I guess, again, the second summary here, fundamentally, the reason we think Tesla has an advantage to the approach that Waymo is using is because it's end-to-end from the get-go. Has been constrained like that. And maybe it's not as good right now, or maybe it is, but it will take some time. It's a bit like Yahoo and Google. It took some time for Google to take over Yahoo. The cost is on Tesla's side. It's going to be a hardware and cost per miles type of situation in the end. And also Tesla has the ground truth of what good driving means. Let's not underestimate that. Thank you.